Here we have a short discussion introducing another mechanical analogy. So I'm trying to get you to have different ways to look at the LC oscillator versus other systems that may be more physical, more easily visualized. So the hydraulic diaphragm pump works as we have shown here, where you can think of kind of like a rubber membrane that's very flexible. So if we pull it to the right, nothing is going on in terms of the movement of the water, but as soon as we release it, it's going to begin to push the water in this direction. And what we're going to be talking about is kind of the velocity of this paddle wheel here in the center, that the velocity of the paddle wheel will increase as the velocity of the water through that tube increases. So initially, we are fully loaded, pulled the membrane to the right, and that is going to be the equivalent for us in our LC circuit with having the capacitor fully charged and nothing going on with the current. So at time t equals 0, we're fully charged up and we're ready to go. Now, when we release the membrane, we get an increase in the velocity of the water, and when we release the capacitor, when we close the switch and let the charge flow, we begin to increase the current. Now, when the diaphragm is directly in the center, we are going to have the maximum velocity of that paddle wheel, and the diaphragm is doing nothing, and that is going to correspond to the capacitor being fully in its relaxed position, doing nothing. And notice that is where we have our maximum current, maximum movement of charge, and that is going to correspond, so please make sure you do get this bit down here, that is going to correspond to 1/4 of a period of motion. So half a period of motion is the polarity is reversed. So now the diaphragm has continued to wobble, oscillate through to the other side. So the diaphragm is going to be fully loaded, because you can think of it as, like I said, kind of this rubbery membrane that's going to bounce back and forth, and as it does, it controls the flow of the water. So when the membrane is reversed, we can think of that as a reversed polarity position for our capacitor. So now we have, again, a maximum, just like the membrane is at a maximum, but the polarity is reversed, and of course the current is now 0, and we are at half of the complete cycle. And again, it just reverses, the polarity reverses, but the same thing happens when the membrane is at its relaxed position, corresponds to the capacitor at its most relaxed position. We get our maximum current. We get no voltage across the capacitor, and that is going to, of course, be 3/4 of a period of motion, and then a full period of motion is back to the very beginning, same position for the diaphragm, same polarity. So we have completed one full cycle, and we are back to exactly the same position. So as I said, very short discussion, but it gives another way of getting a mechanical analogy in here. We're going to go back to the block on the spring in our next lesson and talk about energy. So hopefully this was helpful.